Hi, I'm Alison Smith from the University of Oxford, and I'm going to talk about natural capital mapping in the Arc. So natural capital is the elements of nature which provide value for people. It includes air, water, rock, soil, and all living things. So biodiversity is a key part of natural capital. And we look at 18 different ecosystem services. We've got 4 provisioning services. That's provision of food, fresh water, fish, and timber. 9 regulating services, including control of flooding, erosion control, water quality regulation, carbon storage, air quality regulation, cooling and shading, noise regulation, pollination, and natural pest control. And then 5 cultural services, including recreation, aesthetic value, education and knowledge, interaction with nature, and sense of place. So to develop a green arc vision, what we need to know is where are our high-value natural capital assets already? Where do we need to restore or enhance those assets to provide better services for people, current and future residents of the Arc? What are the impacts of different development scenarios on that natural capital? And how can we create a green network of habitats for wildlife and to connect people as well into a connected network? So I use a fairly simple mapping approach based on a matrix of scores from 0 to 10, which represent the ability of each habitat type to provide each of these 18 different services. And we simply apply these scores to a land use map to generate maps for each of those 18 different services. And on top of the basic scores, we can also apply certain multipliers to reflect things like, is there public access to the land for recreation, agricultural land use quality, which affects food production, and so on. So it's a fairly simple kind of scoping approach. It's not a full natural capital assessment. It's looking at potential supply of ecosystem services. It's not looking at demand, and it's not looking at gaps between demand and supply. And it's not a biophysical assessment, so there's no hydrology in here, there's no economic valuation, but it's a sort of rapid assessment scoping approach. So here's some example maps. The first one is for flood protection. And what you can see straight away, darker shades of green are better supply, and actually it's pretty poor in the Arc because basically the high value areas are the woodland mainly, and we don't have an awful lot of woodland. You can see the Chiltern woodlands down there in the bottom, but fairly poor supply across the Arc so far, and therefore great opportunity to enhance that supply through cost-effective natural flood management schemes. For food production, we've applied the multiplier of agricultural land use class. So this is basically picking out the grade 1 and 2 agricultural land in the Arc, and you can see all the very rich kind of fenland soils over there in the east, and then also some high-value land in the south of Oxfordshire and the north of Oxfordshire as well. And interaction with nature starts to pick out things like the river networks, urban green spaces. You can't see very well on this particular scale, but if you come and see my demonstration later in the other room, we can zoom right in and look at the fine detail of this. So you can't actually add these scores together because you can't add a score of 10 for carbon storage to a score of 10 for recreation and so on. They're not in common units. But what I've done here is I've mapped the maximum score in any particular land parcel. So this shows the kind of high-value assets. The areas of dark green here are areas which score between 7.5 and 10 in at least one service. And what I've done is I've picked out the high-value areas of food production in a different colour, because basically food production and everything else are kind of trade-offs. So in orange, you can see the high-scoring areas for food production, and in shades of dark green, you can see the high-scoring areas for everything else. So you can kind of zoom in, and this is basically a vector map. It's based on Ordnance Survey master map, so you can go right into the fine detail. It maps every single house, roadside, verge, and so on. So the idea here is to show really that conventional maps of natural capital might be mostly white, with just picking out a few nature reserves here and there, but actually all our land is working hard for us, delivering multiple services. Every roadside verge has some value to play in terms of soaking up floodwater, storing carbon, and so on. And what I've done here is I've superimposed one of the MISTRAL scenarios for the new settlement expansion. So although it's quite hard to see, it'll be better if you see my demonstration later. This kind of blocky areas here, outlined in red, are where the new settlement would go. This is one of the settlements between Bedford and Milton Keynes. So you can start to kind of pick out which natural capital assets within that area might be affected by the new settlement. And you can then start to evaluate losses and gains in ecosystem services, which might arise as a result of different development patterns. And this is kind of the next stage of the analysis. We'll be going on to quantify those changes, and also to try and develop a green vision scenario where we see how much development is and what style of development is actually compatible with achieving a net gain in natural capital. This map also superimposes in the kind of lime green blobs some early draft ecological networks or nature recovery networks which have been developed by local groups within the ARC. And I believe these have already been superseded because development is kind of proceeding quite rapidly with these nature recovery networks and environmental opportunity areas. And also in the red, you can see the new settlement scenario, new development areas. So we can start to see how these elements might fit into each other. And we can start to make sure that any new development does not truncate those ecological networks that we need for people and wildlife. So in conclusion, across the ARC in general, intensive farmland really dominates, and therefore there's high scores for food production in many areas. But as a result, there's low scores because there's a lack of semi-natural habitats that provide all the other multiple services, the multiple cultural and regulating services, that those habitats are sparse and fragmented. So it's quite crucial to make sure we don't fragment them further. It also shows that almost all unsealed land has some natural capital potential. So even low-grade farmland can soak up floodwater, store carbon, allow groundwater recharge. But unplanned and unconstrained development is likely to lead to further depletion and fragmentation of those natural assets that we have already, undermining quality of life for current and future residents. So in conclusion, we need to protect those existing assets from further loss to safeguard quality of life, exploit cost-effective opportunities to enhance flood protection and carbon storage, active travel routes, and health and well-being benefits, and to meet nature recovery targets. We can use this approach to test scenarios for future development, including developing a green vision for the ARC, which will build in multifunctional green space and green corridor for wildlife and people. And finally, it can highlight areas of low natural capital value, where there are opportunities to enhance and restore habitats and create nature recovery networks.